When I look up into the night sky, I see not just stars and planets, but the vastness of our universe itself, a universe that is stretching, expanding, and evolving, a process that began some 13.8 billion years ago with a magnificent burst known as the Big Bang. This idea of cosmic expansion has intrigued me for decades, and I have often pondered, how exactly is our universe expanding, and why is it doing so at an ever-increasing pace? As an astronomer, I've spent my career investigating these profound mysteries, and today I invite you on a journey through space and time to explore the fascinating truth behind our expanding universe, a truth that, remarkably, still puzzles scientists around the globe. When Edwin Hubble first observed distant galaxies in the 1920s, he discovered something extraordinary. These galaxies were moving away from us, and the farther away they were, the faster they seemed to retreat. This was our first clue that the universe wasn't static, but was instead dynamically expanding. This revelation was groundbreaking, shaking our very understanding of the cosmos. Yet for a long time, scientists assumed the universe's expansion would slow down due to gravity. It made sense. Gravity pulls things together, so surely the galaxies would eventually decelerate, right? But then, in 1998, astronomers observing distant supernovae stumbled upon an astonishing fact. Far from slowing down, the universe was actually accelerating, speeding away into the darkness. This discovery led us into completely uncharted territory, forcing us to conceive of something entirely new, a mysterious force that counteracts gravity. We named this enigmatic phenomenon dark energy. Unlike anything we'd known before, dark energy seems to permeate every corner of the cosmos uniformly. Even as space expands, its density stays strangely constant, almost as if space itself creates more dark energy as it grows. For the past 2 decades, we have relied upon this concept of dark energy as a constant force, a cosmic accelerator steadily pushing the universe apart. But recent observations have suggested something even more baffling. It appears the strength of dark energy might not be as constant as we once thought. Perhaps, just perhaps, dark energy is slowly diminishing, like easing off the accelerator of a speeding car. This subtle but significant shift has potentially profound implications for the fate of the universe. To understand this better, astronomers have developed new ways to measure cosmic expansion. One of the most fascinating methods involves something called Borean acoustic oscillations, or BAO. Shortly after the Big Bang, the universe was an incredibly hot, dense soup of particles and light. Within this primordial plasma, sound waves propagated, leaving a subtle imprint across space. These imprints now serve as a cosmic ruler, enabling us to precisely measure distances between galaxies billions of light years away. Using powerful telescopes like the Dark Energy Spectroscopic Instrument, DSI in Arizona, we've mapped millions of galaxies, observing their distribution in unprecedented detail. The results have been extraordinary. We now have a clearer picture of how the universe's expansion rate, the Hubble constant, has changed over cosmic history. Astonishingly, these measurements suggest that dark energy's influence might indeed have varied over billions of years. For decades, we've used the lambda cold dark matter model, lambda CDM, to describe the universe. In this model, dark energy is represented by a cosmological constant, a stable, unchanging force. But the latest observations indicate we may need a more flexible model. One such alternative is known as the Chevalier-Pulaski-Linde (CPL) model, where dark energy's strength can evolve over time. This evolving dark energy could radically alter our expectations for the universe's ultimate destiny. If dark energy weakens sufficiently, the universe's expansion might not end in an eternal acceleration, but could gently slow down, stabilizing into a cold, quiet cosmos, a scenario astronomers call the Big Chill. Even more intriguingly, If dark energy diminishes enough, gravitational attraction might eventually overpower expansion altogether, causing the universe to collapse back into itself in a cosmic reversal known as the Big Crunch. Each possibility represents not just a different future for the cosmos, but also challenges our fundamental understanding of physics and cosmology. And yet, within this uncertainty lies beauty, the thrilling realization that the universe still holds secrets waiting patiently to be uncovered. This ongoing exploration reminds me vividly of the early 20th century insights of Albert Einstein, who himself grappled deeply with the concept of a dynamic universe. Initially uncomfortable with the idea of a universe collapsing under gravity, Einstein introduced a cosmological constant into his equations, a kind of mathematical adjustment that later turned out to align perfectly with observations of dark energy decades after his death. As we stand today on the edge of a similar conceptual revolution, I'm reminded that our scientific models are always provisional, always ready to be reshaped by new discoveries. It is precisely this flexibility that drives scientific progress, pushing us forward toward ever deeper truths about reality. One fascinating parallel comes from Einstein's explorations of time itself, as beautifully imagined by MIT physicist and novelist Alan Lightman in his book Einstein's Dreams. Lightman creatively depicts worlds where time behaves in myriad unusual ways, standing still, moving backward, or even looping endlessly. These imaginative scenarios echo the profound flexibility and mystery at the heart of cosmic understanding itself. Indeed, our current understanding of dark energy and cosmic expansion remains incomplete. Scientists worldwide continue to investigate, mapping galaxies, observing supernovae, and scrutinizing the faint echoes of the Big Bang itself, known as cosmic microwave background radiation. Each observation is a step closer to solving the great cosmic puzzle. And as we journey further into the universe, both literally and intellectually, we realize something remarkable. The cosmos isn't merely a distant place we observe, it is our home, deeply interconnected with the very essence of our being. In unraveling its mysteries, we come to better understand ourselves, our origins, and perhaps even our destiny. So when you next gaze upwards at the starry skies, remember you are witnessing a cosmic dance billions of years in the making, a universe whose very expansion narrates an epic story of existence, of growth, and of endless discovery. And while many questions remain unanswered, that is precisely what makes our journey through the cosmos so profoundly beautiful.